Hello students, in today's video we will learn about set operations. So there are many operations which can be done between two or more sets. Here we will discuss three set operations. The first one is union of sets. So if I have a set named A and a set named B, the union of these two sets will be written as A union B. So this is how you will write the relation between union of A and B set, and it is read as A union B. So how will we perform this operation? Now if my set A has elements 1, 2, 3, 4 and the set B has elements 3, 4, 5 and 6. As the name indicates, union means all together. So we will have to write all the elements of A and all the elements of B together as a set. So A separately has 4 elements, B separately has 4 elements. Now when you perform the union operation, you will have to write all the elements of A and B together in a set. So I start with A, 1, 2, 3, 4. Now again I have a 3 and 4 in B. Remember, in the basic concepts of set which I discussed in the earlier videos, I told you that there should not be any repetition in a set. So we will not repeat 3, 4 as it is already there. Do not repeat any element. 5, 6. So 1, 2, 3, 4 came from set A. Again 3, 4 which is there in set B is already here. So the remaining 5 and 6 is written to form A union B. Now the second operation is intersection of sets. Let me take the same example, and the symbol for intersection is the upside down of this symbol. So you will write it upside down. So A and B. So this is read as A intersection B. Now I am taking the same example, 1, 2, 3, 4. And B has 3, 4, 5 and 6. Now intersection means common, where they meet. So they will meet only at the common points. So what is common here? 3 and 4. So A intersection B will have only the common elements. Alright. So union means you will write all the elements. Intersection means only the common elements. Now let me take another example for intersection. I have a set P where my elements are A, B and C. And I have a set Q where my elements are X, Y, Z. Now if I do P intersection Q, I do not have any element in common. If you see A, B, C, X, Y, Z, there is no element common among these two sets. So your result will be a null set. You don't have any elements. So P and Q do not have anything in common. So P and Q are called disjoint sets. Now if you don't have any element in common between two sets, or the intersection of the two sets is a null set, then those two sets are called disjoint sets. So I can define a disjoint set as if there are no common elements between the elements of the given two sets, then those two sets are disjoint sets. The next operation is complement of a set. So if I have a set A, the complement of a set A will be represented either in this form. You put an A and a small c to the right of it at the top, or in this way. Any ways is accepted. So this is how you will represent complement of a set. If you are going to represent complement of a set B, this A will be written or replaced by B. So this is B complement. In any one way we can represent complement of a set, either in this form or in this form. So what is complement of a set? I will explain it to you through an example. Now I have an universal set which has the variables 10, 20, 30. It has elements 10, 20, 30, 40, 50 and 60. Now I have 6 elements in the universal set. Now I have a set P which contains 20, 40. It has two elements 20 and 40. So if I have to find the complement of the set P, so P complement, which can be written either in this form or this form. So the complement of set P is obtained from the universal set by removing the elements of set P. So P has two elements which is 20 and 40. So I will remove 20 and 40 from the universal set and I will write the remaining elements. So 10, 30, 50, 60. This is how a complement of a set is obtained. So complement of any set is obtained by removing the elements of that particular set from the universal set. So another example, the universal set remains the same. I have a set Q which has elements 10, 50. So Q complement will be obtained by removing 10 and 50 from the universal sets. Here now I am removing 10 and 50. So 20, 30, 40 and 60. So to obtain P complement I will remove 20, 40. So I remove 20, 40. I have the remaining 4 elements. To obtain Q complement I will remove 10 and 50. So 2 elements are removed. So I will have the remaining 4 elements 20, 30, 40 and 60. So this is how a complement of a set will be written. To understand the operations better, we will solve an example. Now I have a question written here. I've been given 4 sets, an universal set 1, 2 which has elements 1, 2, 3, 4, 5, 6, 7, a set A which has elements 1 to 5, a set B which has elements 2, 4, 7, a set C with elements 4, 5 and 6. Now the first question here is to find A intersection B union C. So let me start with my solution. To find A intersection B union C. If you see here, there is an intersection and a union. Which one will we do first? So we've already learned in our BODMAS rules that we will always do the brackets first. So whatever is in the brackets will be done first, and then with the result of the bracket we will do the next operation. So first we have to find out B union C because it is in bracket. So B union C. So I have a set B here and a set C here. So B union C, union means all. So I will write 2, 4. So I have 2, 4, 7. We will write a set in order from small to big. So 2, 4, I have 4 here. So I need not repeat it. Next I will write 5, 6 and 7. So let's check if we have written everything. 2, 4, 7 is here. 2, 4, 7. Yeah. And from C, 4, 5, 6 is there. 4, 5, 6. Yes. So we have all the elements of B and C. So we got B union C. Next, A intersection B union C. So this is the set B union C. The set A is 1, 2, 5. 1, 2, 5. The set A is 1, 2, 5. I've written the set A. Next I have an intersection and I need to write the set B union C. What is B union C? 2, 4, 5, 6 and 7. So the intersection means the common elements. 1 is not here. 2 is common to both the sets. And 5. Do we have 5 in the second set? Yes. So 2 and 5 are present in both the sets. Therefore, the intersection is 2, 5. The intersection set has 2, 5. Moving on to question number B, we are asked to find A intersection B union B intersection C. So here we have two brackets. So first we will find the first bracket. Next we will find the result of the second bracket and then find the union of those two sets obtained. So I need to find A intersection B union B intersection C. A intersection B union B intersection C. So to find, first I will solve the brackets. That is the rule. So A intersection B. What is A? 1, 2 and 5. Intersection B. What is B? 2, 4, 7. So intersection means common. What? 1 is not there. 2 is present in both the sets. 5 is not there. Therefore, A intersection B has one element which is 2. The next one I will find B intersection C. So B intersection C, I will have to find what is common in B and C. So B has elements 2, 4, 7. Intersection C. C has elements 4, 5 and 6. Therefore, if we compare both the sets, 4 is common in both the sets. 2 is not present here, 7 is not present here. Therefore, B intersection C is 4. Now, we obtained A intersection B and B intersection C. Now, what is remaining? We have to find the union of these two sets. So, A intersection B union B intersection C. So what is A intersection B? It has only one element. Union B intersection C. It also has only one element. So union means all together. So we will write the elements of the first set and the second set together. So 2, 4. So this is the answer for A intersection B union B intersection C. Question number C is to justify the correctness of the relation. They have given us a relation A union C, the whole complement. This is read, since you have a bracket, it is read as the whole complement. A union C, the whole complement is equal to A complement intersection C complement. Now we have to find the set which is present in the left hand side and the set which is present in the right hand side and check whether both are the same. So to do this, we have a bracket. So first we will have to solve what is in the bracket and then obtain the complement of the set obtained from the bracket. So let us try this. C is to prove. Justify the correctness means we have to prove. So A union C the whole complement is equal to A complement intersection C complement. So first let us find A union C the whole complement. To find A union C the whole complement, first we have to solve what is in the bracket. So A union C is what is there in the bracket. So the set A has elements 1, 2, 5 union the set C has elements 4, 5, 6. So the union means we will have to write it all together. So 1, 2, write in the correct order, 4, 5, 6. So 1, 2, 5 is here, 4, 5, 6 is here. This is A union C. Now A union C the whole complement means we will remove the elements of A union C from the universal set. Our universal set has elements 1, 2, 3, 4, 5, 6, 7. So this is U. 1, 2, 3, it is given in the question. 4, 5, 6 and 7. So A union C the whole complement means remove the elements of A union C from the universal set. So 1 is removed, 2 is removed. I will write down 3, 4 is removed, 5 is removed, 6 is removed, 3, 7. So this is A union C the whole complement. We found our left hand side. Now we have to find the right hand side and prove that they are same. Now this is my left hand side. Now to solve right hand side, I need to find A complement, C complement and find the intersection of them. A complement is A, the set A is having 1, 2 and 5. So you will remove 1, 2 and 5 from the universal set. So when I remove 1, 2 and 5, the remaining elements are 3, 4, 6 and 7. So 3, 4, 6, 7. Next, I will have to find C complement. The elements of C are 4, 5 and 6. So I will remove 4, 5 and 6. When I remove 4, 5, 6, I have 1, 2, 3 and 7. So 1, 2, 3, 7. Now I got my A complement and C complement. I have to find the intersection between them. So A complement intersection C complement. Intersection means we will find the common elements between A complement and C complement. Do we have 1? No. 2? No. 3 is there in both the sets. 4, 6 and 7 is present in both the sets. Therefore, there are only two elements which are common between the two sets. They are 3 and 7. 3, 7. Therefore, if you look at, this is our right hand side, A complement intersection C complement, and A union C the whole complement is our left hand side. Both are having the same elements. So from 1 and 2, we can say that A union C the whole complement is equal to A complement intersection C complement. So we have proved what was necessary. So this is how the set operation works. Hope you will practice more problems and become an expert. Thank you.